Good morning, students. I am M.Yogadharani, working as Assistant Professor in Department of Computer Science and Engineering at SNS College of Technology. In today's session, we are going to learn about a bidirectional RNN, commonly called Bi-RNNs. In previous classes, we studied traditional RNN. We learned that RNN are capable of processing sequential data and maintaining memory through hidden states. So, however, standard RNN have an important limitations. They can use only information from the past. They cannot see future information while making predictions. So, in term of bidirectional RNN, process data into in both directions, that is both the forward direction and backward direction. Because of this, the model can understand the complete context of a sequence. So, example, the bank is near the river. The word bank could mean financial institutions or a river bank. To understand the correct meaning, we need to see both the words before and after it. This is exactly what bidirectional do. So here, before learning bidirectional RNN, let us quick revise the concept we have already learned. That is neural network, feed-forward neural networks, recurrent neural network, and then limitations of vanilla RNN, and then sequential data. A feed-forward network processes information only once. RNN processes information step by step and remember previous information using hidden states. Today, we will see how bidirectional bidirectional improve upon traditional RNNs. So, uh, here is the difference between the feed forward neural network and RNN. And the next slide shows the objectives of bidirectional RNN. By this end of this lecture, you guys are able to understand what is the bidirectional RNN architecture, and how forward and backward processing works, understand why future context is important, identify applications of bidirectional RNN, and compare it with the compare bidirectional with the standard RNNs. Here, these concepts are frequently used in NLP, speech recognition, machine translation. So in this slide, let us consider a practical problem. Suppose we are building a language translation system. A traditional RNN reads words from read only from left to right, right? While processing the current word, it only knows a previous word. It does not know what word will appear next. So the limitation can lead to incorrect interpretation. Example, I saw a rat. The word rat can the example, I saw a bat. Here bat mean a cricket bat or a animal. So the future word helps determine the correct meaning. So in this slide, here a definition of a bidirectional RNN processes data in both forward and backward directions simultaneously. This allows the model to use past context, future context for making better predictions. Here, each problem RNNs is only past data. Traditional RNNs use previous information, and then future context ignored for future contexts are not considered. Here, predictions became weak since the model lacks complete context predictions. Accuracy decreases. Example sentence: the match was exciting because the last over changed everything. Here, understanding exacting becomes easier when future words are available. So this is the definition part of RNN. So ideate. Here, what are the possible solutions for this problem? Here is deep recurrent neural network, long which use for multiple recurrent layers, and LSTM stands for long short-term memory. Here, designed to remember information for longer periods. GRU stands for gated recurrent unit. This is a simpler version of this one, long short term memory. And then attention mechanism. Here it allows the model to focus on important parts. And then bidirectional. Here bidirectional uses both past and future information. So the best possible solution is bidirectional RNN is efficient because it combines information from both directions. It understands sequence context more effectively. So in this slide, services or features of bidirectional RNN. First one is past context, which means learn information from the previous elements. And here the future context that refers to the learn information from the upcoming elements. And better sequencing learning means it captures relationship more accurately, and then improve accuracy, which refers produces better predictions compared to standard RNN. And then real life example here is a Google Translate uses contextual information from both sides of sequence sentences. Here see bidirectional RNN, it consists of um, forward process and backward process. Here x1, x2, x up to x4, these are up to xi processes. Here backward processes are x4, x3, x2 up to x1. Here hidden states are each RNN. Here each RNN maintains its own hidden layers, and combination layer, it means combined layer is used for both both directions are merged. Outputs from both directions are merged here. And then final output shows the generated using combination combined information. Here the key point is this model sees both the past and past and future before making a decision. So this is the bidirectional forward pass. Here forward RNN works in a normal RNN. Here input arrives. Here hidden state H1, H2 stands for hidden states, and output generated. Here this model learns information from the previous inputs. Here example is I love deep learning. While processing learning, it remembers I love deep. And then and the next slide is bidirectional backward pass. Here see this example. Backward process sequence in a reverse order. In a reverse order, it learns information from the future input. Example, I love deep learning. While processing deep, it already knows learning is coming. This provides richer context. And this is the working of a bidirectional RNN. In step 1, input sequences are provided, and then forward RNN learns from the past one, and then backward RNN for the future context, and step 4 for hidden states are combined. Final predictions generated. Here bidirectional RNN combines two perspectives before making a decision. And then applications of RNN are speech recognition, machine translation, sentiment analysis, handwriting recognition, named entity recognition, question answering system likewise. Example, ChatGPT like systems are use contextual sequence processing. And this is the mind map of a today's session. Deep learning, RNN. What is the limitation of RNN? Then why we go for bidirectional? Or it's working. We saw about what is the architecture of bidirectional, and it's working under the applications. Thank you. Catch you in another video. Bye.